All right, so to kickstart this presentation, it's going to be just a high-level overview um, of how to become a data specialist. So we'll be looking at the various data specialties, and then we'll also be looking at the various skills and tools that we need to be able to work efficiently in these roles. So to start off the presentation, first, we'll be looking at the data in scope, where we'll have a high-level overview of what data basically is and why organizations are so interested in data. And then next, we'll also be looking at some of the data specialties as well. And for this, we'll be looking at just 3 high-level data specialties. We'll also be looking at a couple of roadmaps, tools, and then resources. And then some nice to have skills as well. And then next step, and then finally, we'll look at how to search for jobs, right? A comprehensive CV, and then a cover letter. So without wasting much time, let me briefly describe, tell a bit about myself. So my name is David Adarkwa, and I graduated with a BSc in Biomedical Engineering from KNUST here in Ghana. And then I worked as a data scientist for Amalitech Services before moving to CBG as a data scientist, where I currently work. And then I'm also the lead ML engineer for DataWare Tech Ghana. And I'm also part of the participants for the yearly I Experience Summer Program, where I act as a teaching assistant for the data science and analytics track. So firstly, we want to have a high-level overview of why organizations use data and then what they use data for. So almost every organization in Ghana or across the world wants to become data-driven. And as such, most organizations extract or create data one way or the other. So the overall goal for every data-driven organization is to basically extract meaningful insights from data sets to help drive decision-making. Now, for whatever reason they use these insights to achieve is dependent on the particular role or the objective of the organization. So for an organization who wants to perform a more forward-looking analytics, which I'll explain going forward, we'll look at recruiting people or data specialties in that domain. And for organizations who want to specialize in more data backward-looking, we'll also look to recruiting people in that domain. Now, how do organizations use data to drive decision-making? This is why we want to look at the various analytics processes that takes place in every organization who wants to become data-driven or who is data-driven. So firstly, we look at descriptive analytics, which basically allows the organization to understand what happened previously. So if there is a dip in sales, descriptive analytics will basically give us an idea as to why there is a dip in sale and then what actually happened. So for diagnostic, we are also looking at why the incident happened. So just as I said earlier, if there is a dip in sales for a particular period, we also want to explore why that particular month had a dip in sales as well. And then we have predictive analytics, and then we have perspective analytics and cognitive analytics. So for predictive analytics, we are looking at forecasting future outcomes or predicting what might possibly happen in the future. And then perspective analytics is to decide what should be done when such an occurrence takes place. And then cognitive is to basically look at ways and means by which we can ensure continuous flow and automation of some of the predictions that we make into the future. So on a high level, descriptive and diagnostic analytics basically fall under what we call backward-looking analytics. And then predictive, perspective, and cognitive falls in what we call the forward-looking analytics. Now, for each of this domain, there are data specialties involved in executing tasks in these domains. And that is what we want to look at. So for the forward-looking analytics, we are looking at data analysts. So these are people who dive into the data and then extract insights from the data to allow organizations answer what happened and then why those things happen. So in a nutshell, I also describe some of the rules of data analysts and what they do, as well as the skill set and resources to start a career in that area as well. Now, in the more forward-looking analytics, we are looking at machine learning engineers. So unlike data analysts who basically extract insights to help organizations make data-driven decisions, machine learning engineers leverage on this insight that has been extracted to help organizations predict or forecast into the future. So they deal more with the forward-looking analytics, while the data analysts deal more with the backward-looking analytics. Now, where does the data scientist come in? So for the data scientists, they combine both data analytics and then machine learning engineer to help drive decision making. So they take a bit and pieces of data analytics, which is descriptive analytics and diagnostic analytics. And then they also take bits and pieces of machine learning as well, which is predictive analytics and perspective analytics, to help businesses, to help drive data-driven decisions for businesses. Now, the next thing we want to look at is why the high rise or the high demand for some of these data specialties. So this is a line chart showing the various data specialties and then how the trend has been over a period of time from 2004 to present. Now we can see that right before 2015, the demand for these data specialties was a bit linear. In that for machine learning, which is the gray colored line, and then data scientist, which is the blue colored line, data analytics, which is red, and then data engineer, which is yellow. The demand was relatively normal. But then when it got to 2015, there was a high or spontaneous increase in the demand for or interest in some of these data specialties. So we can see data scientists and then machine learning engineer demand soaring as high as almost close to 100. And then we have data analytics also in the mid-level point around 50. And then we also have data engineering also soaring around 20 to 25. Now, what is causing this high interest or high demand for these data specialties? That is what we want to look at next. So first and foremost, it has to do with the explosion of data. Back then, we were collecting data all right, but we could also understand that our memory capacity back then was a bit low. For someone holding, let's say, 1 gigabyte of external or SD card could actually do a lot with that SD card. However, the data that we were producing back then was so huge that we didn't have the memory capacity to be able, the storage capacity to be able to keep them. Now there is digitalization. There are digital watches, there are laptops, there are streaming sites, there are social media platforms, and then every now and then data is being generated every second. So this calls for more sophisticated algorithms and fields to be able to transform these data sets that are being generated into actionable insights. And that is what is actually one of the reasons why data specialties such as data science, machine learning, data engineering has soared from 2015 till now. And then secondly, we also have strong compute power. Just like I said, now we have huge RAMs, we have complex or complicated CPUs that can perform complex tasks as well. And then we have the cloud platform as well, which has multiple or distributed systems for processing data at scale. And then the last is statistical methods. Now we have complex algorithms as well that can help us generate insights from huge data sets. So if back then we were using the simple linear regression to generate insight from data, now there are more complex algorithms like decision trees and random forest that allows us to extract these insights from data. These are the top 3 reasons that contribute to the demand for some of these data specialties. Now, the next thing we want to look at is out of these data specialties, what specifically do they do? Now, last year I had the opportunity of training participants for this same conference on how to complete a data science project from start to finish, from problem understanding to model deployment. And it was a more technical session, but after the program, I had a couple of them reaching out to me on LinkedIn that they really like the session, all right, but then they are amateurs. Now they want to look at various resources that can help them start their career in this field, and that they are really, really interested in the field. That is when I got to understand that for this session, most of the people that will be partaking in this session are not really technical people. And that is what led to this particular session as well. So this session is more or less like an information session, or giving a high level overview of the various data specialties that we have, and whichever piques your interest, what are the resources and skills or tools that you will need to be able to start a career in that area. So let's take a closer look at the various data specialties. And just as I said, there are a lot of them out there. But for this particular session, I'm going to look at the top 3 data related specialties, which form the backbone for the other data specialties as well. So first and foremost, we want to look at the data analyst. Now, just as I said, data analysts are more interested in the backward-looking analytics. That is the descriptive and then the diagnostic. So what they do is they analyze data using the descriptive and inferential statistics. They want to look at the average sales revenue that was generated month on month. They want to understand if there is a cause or there is a particular instance where a hypothesis that they came up with is the cause for something happening. That is where they leverage inferential statistics. Now, another thing is, for every data analyst to thrive in their role, they need to access data. Data serves as the foundation for every data analyst to work. So for every data analyst to be able to perform their tasks, they need to have access to data. Data comes in different formats. It might be in Excel sheet, it might be in CSV, it might be in a text file. Some of them might also be in a databases as well. And there are a lot of organizations out there that store their data in databases, which means that for a data analyst to be able to perform their role, they need to have a thorough understanding of how these databases work and how they can extract data from these databases to perform their tasks. So data analysts use what we call structured query language, which is the programming language for accessing a database to extract and then manipulate data. Then the next thing is, once they have the data, what they do is they filter, they clean, and then they transform the data into a suitable format that they can use to generate insights for the organization. And then finally, once everything has been completed, data has been extracted, transformed, and then insights generated, they need to communicate the results to various stakeholders using various tools and techniques. And one of them is various reporting techniques and then dashboarding techniques, as well as PowerPoint presentation as well. And then they also work with management to understand various business requirements. And that is something that we'll be looking at next when we start talking about the roadmap to becoming a data analyst. Now, why are people interested in this field? Is a question that keeps coming up every now and then. We've looked at the result for the rise in these data specialties. And now one of the other reasons, apart from the 3 that I listed earlier, is how rewarding the field is. So for someone who has spent months or years equipping themselves in this particular role, might end up with a job that will be financially sound for them. So the data analyst earns an annual salary of about $71,000, and this comes from Glassdoor. Again, this is just for information's sake. However, this salary, the average annual salary, varies from region to region. But the bottom line is, for everyone working as in this data analyst role in every country, will end up having a rewarding financial opportunity in this role. Now, we will also want to have a look at what data scientists specifically do, and then what their average salary is. We've looked at the various tasks performed by a data analyst. Now, for a data scientist, they basically perform similar roles just like data analysts, but there's a small difference between how they perform their tasks. Now, for data analysts, just like we said, they extract insights from data, and then they use the data to answer the questions such as what happened, why those things happened. Now, for data scientists, they look at the data analytics pipeline in a whole different angle, in the sense that they get the data, generate insights from the data. It is what they use the insights for that differentiates them from a data analyst. So a data scientist picks up the insight and then use that insight, or is informed by that insight, to make predictions into the future. Now, for them to be able to achieve this task, they perform what we call data wrangling, which is similar to the data analysis process. So they collect data, they transform data, they combine data from different sources, and then they wrangle the data set to become a uniform whole for what is to happen next, which is machine learning. Now, data scientists use machine learning tools. When I say machine learning, it's basically techniques that are used in programming computers to make predictions into the future based on data that has been acquired. Now, once this has been done, the output can inform business on the next steps to take as well to resolve those issues. So data scientists use machine learning tools to forecast and classify patterns in data. And then they also perform model fine-tuning and performance optimization. So let me break this down here. So we have a data set, and then we have an algorithm. An algorithm is basically the process of extracting insights from data, or the process of completing a task in a nutshell. Now, when we go into the data and we extract the insights from data, and we use that insight to perform prediction into the future, that is what we call predictive analytics. And the process or the technique for doing that is what we call machine learning. Now, once that has been done, the algorithm, that is a series of steps taken to be able to extract the insights, has been completed. The whole package, which is the algorithm together with the insights generated, that can be able to make prediction into the future, is what we call machine learning model. Now, because machine learning model depends on data, over a period of time, data changes, right? And then the performance of that model also changes. As a result, one of the tasks that data scientists perform is to fine-tune this model based on new data that has been acquired, just to optimize the performance of the model in order to make accurate predictions, and then also help business to make the right decisions. Another task that data scientists perform is to translate complex business problems into data science use cases. And then just as I mentioned earlier about machine learning models, once those models have been built, data scientists deploy these machine learning models to be used by various business stakeholders and then users. And then finally, they use robust storytelling tools to communicate results to team members. Data scientists earn an annual salary of $124,000 on average. And again, this is also dependent on the region you find yourself in. So for someone who is in Ghana, just as I said earlier, the salary you earn as a data scientist is quite rewarding and is quite comfortable. However, I know that people are always motivated to go the extra mile, and probably they might even want to earn more than this. But in a nutshell, it's just the field is rewarding for anyone who wants to become a data scientist. Now, data engineering. So data engineers form the backbone for every data-related task, right? Every other specialty relies on data engineer. They eat and breathe data. So data engineers basically develop and construct and maintain data architectures. So everything that allows us to extract data, to transform and load data into a suitable and maintainable location is performed by the data engineer. Without the data engineers, we wouldn't have that suitable data or the streamlined data we use every now and then to perform our complex tasks for data scientists, machine learning engineers, and then data analysts. So data engineers are extremely important for every organization out there. Now, another task that is performed by data engineers is conducting tests on large-scale data platforms to ensure that the process of extracting, transforming, and loading data is streamlined and there are no errors or bottlenecks along the way. They also handle error logs and build robust data pipelines. So the process of collecting data to the process of storing data, everything that happens within this pipeline are built by data engineers. Now, data engineers work with different variations of data. They work with unstructured data and they also work with structured data. So structured data is basically data set that can be fit into rows and columns. An example is the data set that we have in our Excel sheet. And we can also form relations with this data. Now, for unstructured data sets, they are data sets that are basically difficult to put into rows and columns or in a structured format. An example is social media comments or social media data, streaming sites, and so on and so forth. Now, they also provide recommendations for data improvement, data quality, and efficiency of data. They also ensure and support the data architecture utilized by data scientists and analysts. Just as I said earlier, every other data specialty sits on data engineer. It's a very, very robust field. And if you are willing to go into the field as a data engineer, then you really have to get up your loins because it's not an easy field. Most of the things that they do are super technical. And because it's rewarding, you get a lot of daring people going into that field as well. Now, they develop a lot of data processes for data modeling, data mining, and data production. So in a nutshell, or at a high level, Those are some of the tasks that are performed by data analysts, data scientists, and data engineers. Whichever piques your interest, understand that the bottom line is you will be working with data, and you'll be working with defined skill sets and tools that can help you become efficient on the job. And that is the next thing that we want to look at. We want to look at how we can define a clear roadmap, or what are the tools and resources we need to be able to zoom into a career, a data-related career. So for someone who wants to go into a data analyst domain, what are some of the requirements or tools and skill sets you need to be able to go into that domain? The same applies for data scientists and then data engineer. So we begin with the data analyst. So for the data analyst, the very first skill set that you need to have at your beck and call is a problem-solving skill set. Every data analyst out there is a problem solver, right? So as a result, there is a defined pipeline that every data scientist goes through to be able to solve their problems. Let me make this clear. Every data science pipeline or every problem that data analysts, data scientists, or data engineers solve is totally different. However, there's a framework that allows us to follow a clear path to solving some of these problems. It might not be followed strictly, but most of the times this framework is what guides data analysts into solving some of their problems. And this is what we call the CRISP-DM framework, or the cross-industry standard process for data mining framework. Now, the very first part of this framework is the business issue understanding. Data scientists sit with various business stakeholders to understand the problem that they want to solve, then come up with methodologies to solving those problems, as well as the kind of data they will need to solve these problems. They go ahead to perform what we call data wrangling, just as I said earlier, to understand the data as a whole, to assess the quality of the data, and then perform what we call data preparation, which is the third step, to prepare the data suitable for analysis. The next step is to perform analysis and modeling, and then validate the results that they've come up with and the insights that they've generated. And then finally meet with various stakeholders and present their insights to them. Now, for someone coming or going who is interested in the field of data analysis, what are some of the resources out there that can help you have a solid foundation, have a solid problem-solving foundation? Now, one of them, some of the resources is what I've listed here. We have problem solving with advanced analytics. This is a free course on Udacity, which breaks down each of these framework, as well as the questions that you can ask when you go for any stakeholder meeting, the kind of questions you can ask when you want to understand the data, as well as data preparation, and then the kind of processes you go through to be able to analyze, validate, and communicate your findings. Now, there is another program called the McKinsey Forward Program, which trains young professionals out there with digital skills, as well as problem solving and creative thinking skills as well. So I didn't add timelines to this because we all come from different fields and we all learn at a different pace. Sarah, you raised your hand. Is it Sandra? Hello, Sandra. All right. Please, as I'm presenting, if you have any questions, just write it down, and right after the presentation, I'll give some time to answer all of those questions as well. Thank you. Now, we've looked at the problem-solving framework. What is the next thing a data analyst is supposed to do, or what is the next skill that is required to be able to execute your function properly? So we have statistics, probability, arithmetic, and algebra. For a data analyst, you'll always be working with data. And for you to extract insight from data means that you'll be working with numbers as well. You'll be doing a lot of statistics, you'll be doing a lot of probability, you'll be doing a lot of arithmetic and algebra. And just as I said earlier, most data analyst positions will require you to have a basic understanding of mathematics, and then also apply some of these techniques in the job as well. So what is it when I tell you that the average sales for a particular month is this amount? How do you explain this to various business stakeholders? How do you communicate your findings using hypothesis tests? So I assume that probably one of the cause for this problem is this. Then I go out and perform what we call hypothesis testing to be able to test if this assumption that I'm making is valid, right? So we make use of statistics, probability, arithmetic, and then algebra a lot of the times. And here are a few resources to help you get started with some of these tools as well. So we have descriptive analytics, we have inferential statistics, we have linear algebra, we have arithmetic, and then we have statistical analysis. The next skill set that a data analyst needs in their toolbox is what we call data acquisition and databases. And when I was describing the various tasks that data analysts perform to be able to extract insight from data, one of them was to query a database to access the data. This is always sorted out by the data engineer. Now the question is, what if you go to an organization and there is no data engineer? What if you go to an organization and there is no data available? What do you do as a data analyst? These are some of the things that most data analysts experience a lot of the times on the job. I remember when I was working at Analytics Services and we wanted to evaluate employee salaries. We didn't really have data sets available, and every organization out there who had the data available were charging us huge amounts of money in dollars just to be able to get access to that data. So as data scientists, what we did was to prepare a survey and then send the survey out to various IT professionals, requiring that they give us a breakdown of what they earn, not specifically, but in a range, as well as other information. And once we received that data, I think we had responses for about 500 people. And once we received that data from the survey results, we were able to analyze them, which basically informed the organizations to increase employee salary. Now, most of the times, data analysts work with data from different sources. And as a result, just as I said, you might not have data readily available in a database. How then do you collect data to be able to perform the tasks that you want to perform? And one of the techniques is scraping data from the website. This might be a bit technical, this might not be technical, dependent on the kind of problem that you want to solve. Mostly for data analyst jobs, this kind of analysis or this kind of technique needed for scraping web data, it's not really too technical, right? So I've also provided a couple of resources down there, and then they also collect data through surveys. And then just as I mentioned earlier, they query relational databases. So there is a fantastic add-in or Google plugin out there called Web Scraper that allows you to easily scrape data from websites to perform your analysis. And they have tutorial videos as well to aid you to understand how to use the tool and then the plugin. And then I've also provided a resource for relational databases, how to work with relational databases, and then also how to design an effective survey and how to extract data from survey into Excel sheets and CSV files. I'll make this presentation accessible to the organizers and they'll share it with you once the session ends. So you need not worry about getting the slide. Now, the next bit is programming for data analysts, which is one area that a lot of young lads out there fear or are not really interested in. But then you can't work as a data analyst when you don't want to program. It's not possible. You might work all right with Excel, and depending on the amount of data that you're working with, it might be suitable for you. But then in order for you to be effective with huge data sets, then there is the need for you to be able to learn one or two programming languages. And the most popular of them all is Python and then R for data analysis. So most data analysts have extensive understanding of Excel and then SQL. Most data analysts sleep and breathe in a relational database because that is where they get their data from. That is where they can source their data from. Some of the data also come in different formats like Excel and then CSV. So they are pretty conversant with analyzing data from Excel sheets. Now, the limitation with Excel is that Excel cannot process huge amounts of data. This is where we need various techniques and programming language to be able to transform that data into the suitable formats that we need. Data analysts are not expert programmers. Let me make this clear. Data analysts basically need to have a foundational understanding of programming and be able to do the simple things that are required to solve their problem. So some of the programming languages, just as I said, the popular ones are Python programming and then R programming. I've also provided a resource for learning SQL as well. If you're someone who is now gearing up to the data analyst field, it will be very, very important that you also look at SQL. Now, the next bit after programming, after learning one or two programming languages and becoming conversant with them, is to use those languages to perform what we call data exploration, reporting, and dashboard. Now, there are different formats of reporting and dashboards, and I'll talk briefly about it. So data analysts build and automate reporting dashboards for visibility and stakeholder engagement. After going through the entire data science pipeline, understanding the problem, collecting the data, preparing the data, now it is time for me to analyze the data, right? What are the tools and resources available for me to be able to analyze the data? After analyzing the data, how do I want to present the result out there? What data analysts basically do is they generate what we call summary reports, which is one of them. And then they automate this report. So probably they want the summary report to run every month, every day, or every week. Based on the frequency of the summary report, they automate these processes just to achieve those tasks. Another way that data analysts present their findings is through dashboarding. So they build sophisticated dashboards that allow various stakeholders to drill down into whatever is happening in the organization and how those processes are happening. They also build dashboards to monitor the performance of certain processes in the organization. Some of the tools that data analysts use in performing this task includes Power BI. They also use Excel. They use Tableau as well. And then if you are confident with programming, then you would want to use Outshine, which is a very nice framework for building web applications and then complex dashboards as well. And then we have Plotly as well. If you want to build interactive dashboards using Python, then you can also explore this. Now, the final bit of the data analysis skill set or toolbox that every individual who wants to go into the field needs is communication and presentation. Your work is never complete until you are able to communicate your insights and findings to various stakeholders. As such, it is important that as a data analyst, you build your communication skills and your presentation skills. Whatever findings you come up with, you should be able to decipher all of these findings, break them down into understandable chunks, and then deliver to business to assimilate all of the insights that you've generated. Now, I must say, communication and presentation is not easy. Every other thing we've mentioned out there is either technical or probably you have time to do. But for communication and presentation, it's something that you have to build upon, right? It's not something that comes off the hood as if, okay, so once I'm done with the analysis, let me just go to business and then present it to them. No, you have to look at the audience that you'll be presenting the insights to. What is expected? Are you answering the goal? Are you answering their question? Make sure that you've broken this down into individual components such that it can easily be assimilated by business. Every other person out there or business stakeholder is not too technical like you, the data analyst. So it is important that you are able to structure your communication in such a way that it can easily be accepted or assimilated by the stakeholders. Now, again, just as I said, this is not something that comes off the hook, right? It's something that you build upon. So every now and then, when you go through your data science pipeline and then you generate your insights, you build your dashboards, try as much as possible to understand it yourself and then see yourself from the business or the stakeholder perspective. What are some of the questions that you might want to ask? What are some of the answers that you might expect? And then be able to communicate these solutions efficiently when the time comes for you to meet the stakeholders. Now, there are a couple of resources out there that allows data analysts to be able to perform these tasks efficiently. One of them is through PowerPoint presentation. Another one is through infographics, which is just a summary output of everything that you've come up with images, visualizations, and then just a few texts. And then another thing is public speaking. There are times where you might have to present to a large group of people or a large stakeholder, just to be able to break your insights down for everybody in the room to understand. And this is something that every data analyst also has to improve, public speaking. And then there's email etiquette. Once you generate the report, once you come up with a dashboard, how do you communicate with the various stakeholders? How do you remind them? How do you notify them that you've been able to achieve whatever they wanted you to achieve, right? And then the next bit is documentation. After you've gone through the entire data analysis pipeline, you must try as much as possible to document everything that you went through, from data quality checks to data preparation to questions that you answered to the goal of the problem that you're trying to solve, and then to the various tools and resources that you use in generating those insights. This is because you are not always going to be there, right? So when someone comes in and someone picks up your work, how are they able to break this down into chunks, into understandable chunks? And how are they able to navigate through the analysis you perform to be able to understand it as a whole? So this is where documentation becomes very, very important. So on a high level, we've looked at the various skill sets and tools and resources that you will need to kickstart your career as a data analyst. To make this clear, this is only at the foundation level. Every data analyst, data scientist, and data engineer always needs to build a solid foundation to be able to traject to the other main or complex domains. So you will see along the way that data scientists also need to acquire this data analysis skill set in order to perform the more complex tasks, which is machine learning. So on a high level, these are some of the skill sets that every data analyst needs to achieve on the foundation level to be able to kickstart their career as a data analyst. Now, the next thing we want to look at is a data scientist. When I started the presentation, I broke this down, data scientist and data analyst. I mentioned that data analysts focus more on the backward-looking analytics, that is descriptive and diagnostic. For data scientists, they combine both the analysis bit and then the machine learning bit to drive decision-making for organizations. So for this section, we want to look at the various skill sets and tools that we need as a data scientist to work efficiently in our role. Now, the very first thing is the data analyst roadmap. This is constant. Every data scientist needs to have data analysis experience, right? So this is the reason why I said for you to be able to zoom into a career as a data scientist, it will be great or it will be important for you to go through the data analysis process or phase before you think of going into the data scientist domain as well. So everything that encompasses the data analyst roadmap is also needed in the data scientist roadmap as well. So data scientists possess solid understanding of programming language and deep understanding of linear algebra, calculus, and further mathematical disciplines. The only difference between the data scientist roadmap and the data analyst roadmap is that it is optional for data analysts to have sufficient experience in programming languages. However, for data scientists, it is not optional. Everything you do requires you to know programming as a whole. So for someone who wants to go into data science, the person needs to have a solid understanding or a solid foundation in any of the programming languages of their choosing. And then secondly, I mentioned that for data analysts, we use statistics, probabilities, arithmetic, and then algebra to solve some of our problems. But for data scientists, they go a bit further in the mathematical domain. They look at calculus, differentiation by parts, and other mathematical disciplines such as optimization, metrics, computations, etc., to be able to solve their problems. So data scientist is a more unified domain that encompasses both data analytics as well as some of this complex stuff that you have to learn. So you have to be familiar with calculus, you have to be familiar with Python programming, and then also be familiar with Python and R libraries. Again, this is a programming language I included here because of its popularity. However, if you're familiar with Java, if you're familiar with C, C#, whatever programming language you're familiar with, just make sure that you can use that language to perform the tasks that you have to perform as a data scientist. Another bit is for data analyst, you work more with structured data in a relational format. So you work with relational databases such as SQL Server, MySQL, and so on and so forth. But for data scientists, we look into NoSQL databases as well, and then distributed platforms as well, where we store data in a more distributed platform, like big data technologies like Hadoop and then MapReduce. So data scientists also need NoSQL database expertise. There are a couple of popular ones out there like MongoDB and then Hadoop as well. So I've provided resources if you want to look at each of this just to brush your skills or just to get an understanding of what calculus is, what Python is, as well as the libraries. Then you can visit some of these resources as well. Now, the interesting bit about data science is the machine learning part. So data scientists focus more on the forward-looking analytics, which I've said before, where they build machine learning models to predict future outcomes. That is the differentiator between data science and then data analyst. So once we go through the entire data science pipeline and we come up with insights, the insights should inform us or give us a clue as to how we can build our models to predict future outcomes, right? So for data scientists, they build a lot of machine learning models using various tools and techniques. Just as I said, you can't become a data scientist without having sufficient programming experience. So I've also provided resources out here that will give you a comprehensive understanding of the machine learning scope. ML Zoom Camp is very, very good if you want to understand the machine learning or AI scope. ML Zoom Camp will break everything down for you to grasp the concept. And then there is machine learning concept. This is a platform that I use extensively just to be able to get an understanding of the nitty-gritties of what goes on under the hood in machine learning. And then we have machine learning interpretability. The overall goal of data scientists is not just to build fancy models and then deploy them for people to use. The overall goal is to build these models to help business drive decision-making, right? To help generate value for the business. So it is important that every machine learning model that you build, you are able to interpret it in the business sense. And this is where machine learning interpretability comes in. If you build a linear model that says that y is equal to mx plus c, what will happen if m should change? What will happen if c should change? This particular platform allows you to have a feel of what interpreting machine learning looks like in the business sense. And then we have machine learning mastery, which talks about the various or different concepts in machine learning as well. Now, the next thing that every data scientist will want to be abreast with is time series forecasting. Every now and then, data scientists work with different formats of data sets, and one of them is time series data, which is basically date-related data. Now they pick up this data, and just as we see for machine learning, they generate insights from this data, and the process of generating insights from a time series data is what we call time series analysis. And that is what we saw initially with the line chart when we were looking at the various interests for various data specialties. Now for time series forecasting, just as data scientists work in relation to data analysts get the insights, they generate insights from the data to perform more backward-looking analysis. Data scientists generate insights from data as well, but they use these insights to predict or forecast the future. It's the same process with time series forecasting. First, you go through the time series analysis phase to come up with the insights, the trend, the seasonalities, and the various differences in your data. Once you come up, you're able to see some of this insight from the data. It will inform you on what the forecasting should look like, or it will also give you a clue as to why we are able to forecast this or why we are getting this result. So time series forecasting is very important for every data scientist because, for example, if you're working in an organization, let's say an e-commerce organization, and then they want to predict their sales for the next 6 months, this is where time series forecasting becomes very, very important. They have data, they have sales month on month for the past 3 years. So you can pick up this data, use various tools and techniques which I've listed down here to be able to perform what we call time series forecasting, which will predict the amount of sales that a business will generate within the next 6 months. So these are some resources to get you started with time series forecasting, and then some of the tools as well. Now, the next thing for machine learning data scientists is MLOps and software engineering principles. MLOps is similar to that of DevOps, but this is specifically for machine learning or for AI. It basically encompasses all processes that a data scientist should go through to deliver the right solution to business. In this case, we are looking at everybody involved, that is the various stakeholders, every department, and then we're also looking at every tool involved that will allow us to achieve our goal. If a data scientist should go through the entire process of building a machine learning model, should they sit on their computer and then be using the model by themselves? No. So they basically have to deploy the model out there for people to use. And deploying model is not like pick and drop. No, there is a process or a pipeline that you have to go through to be able to deploy a reliable model, be able to maintain and monitor it. The process of going through this entire pipeline is what we call the machine learning operation. And to be able to do that, you need a bit of software engineering principles. I mentioned that data scientists can't do away with programming. Every bit of everything we do requires programming to be able to achieve our tasks. So every data scientist must have a fundamental understanding of software engineering principles to deploy, improve, monitor machine learning models. Now, I've also provided a few resources down here for anyone interested in the field to take advantage of. So we have MLOps tutorials, and then we have MLOps Zoom Camp, just as we have for the data science Zoom Camp. So MLOps Zoom Camp is also another very good program organized by Alex Gregorov. And if you want to have an understanding of software engineering principles and practices, then you should also endeavor to take the AWS Machine Learning Foundation course. So they'll teach you about Python programming, they'll teach you about object-oriented programming, and then they'll also teach you about some of the software engineering principles. And at the end of the day, you also build your own package that you can use for your various data science tasks. And again, machine learning interpretability also comes up here again. So that is all for data scientists. These are the various skill sets you need to become a data scientist. And then the next bit is data engineer. So data engineer is a bit and pieces of various tools and techniques that are used to extract, transform, and load data into what we call a data warehouse. A data warehouse is a centralized location where we keep and store and maintain data. So for data engineer, you need a programming experience. It is experience that you know how to program, either in Python, in R, or any programming of your choice. And then the next bit is operating systems and command line. Data engineers work with a lot of server. They work with server with different operating systems. They might be working with Windows operating systems. They might be working with server seated on a Linux operating system. So to become a data engineer, you need to have a thorough understanding of the different operating systems, as well as how to navigate your way using the command line. Just as I said, every data specialty sits on top of data engineer, and they are the backbone of everything that we do. If data engineers are not available, then it means that systems might fail. Systems, if there are any issues, it might be difficult to resolve them. That is why they are really, really important in every organization. So data engineers try as much as possible to make sure that every system that they put in place is functioning properly, and there are documentations to resolve issues if they come up and if they are not present. And then the next bit about data engineer or skill set that you need is data modeling and then architectures. So you might build what we call relational data models, where you build relationship between different tables, or you might build what we call non-relational models, which are basically for unstructured data as well. And then you build architecture such as data warehouse and data pipelines, and then ETL pipelines as well, just to be able to ensure that data is moved from its source to a centralized location that can be tapped and used by other data specialties like data scientists and then data analysts. Now, data engineers work a lot with relational and non-relational databases. This is where, just as I said, data engineers sleep and breathe data. So wherever data is, you'll find a data engineer there. So they work a lot with relational and non-relational databases. So if you're a young lad out there who wants to start your career as a data engineer, then you need to have the skill set that I've listed up here. You need to be good with programming. You need to also have sufficient understanding of operating systems, especially Windows and then Linux. You also need to be familiar with the command line, how to navigate your way with command line. You need to be able to build data of relational data models and then non-relational data models. You need to have a thorough understanding of data warehousing. and then how to build pipelines to move data from one end to the other. And then finally, a data engineer also has to be familiar with big data technologies and cloud computing. Cloud computing, because just as we mentioned earlier, data engineers extract data and then save them in a centralized location. When data becomes full, when the space for storing data becomes full, then we look at other options of storing the data. This is where cloud technologies become the expedient. So data engineers look at the various techniques, resources, and applications available in the cloud that will allow them to be able to scale when the data grows as well. And then they are also familiar with big data technologies. The way data scientists and data analysts handle data in smaller quantities is totally different from how data engineers will handle terabytes and petabytes of data. And this is where big data comes in. When data is being generated at high volume, at high speed, and from different sources, it needs sophisticated tools and techniques to be able to do that. And this is where data engineers shine as compared to data scientists and then data analysts. Now, one top resource that I recommend to everybody who wants to start their career as a data engineer is to look at the data engineering Zoom camp organized by Alex Bergroth. This will give you a thorough understanding from the beginning what data is, what structured and unstructured data is, what relational and non-relational databases are, and how to work with various tools and techniques to be able to build the pipelines, the architectures, and then model data correctly to be used by other data specialties. Now, what are some of the nice to haves for all the data specialties that I mentioned here? So first and foremost, you need to have cloud computing skills. Now, most organizations are moving to the cloud because the on-prem resource is not really sufficient to be able to hold up whatever resource that they have. And then also for organizations to be able to scale appropriately and then flexibly, then they need to leverage on resources from the cloud. Unless you basically have enough money to acquire resources on-prem, then it will be expedient to move for organizations to move into cloud. And this is what most organizations are doing out there. So if you're a data scientist, a data analyst, or a data engineer working in an organization whose data is seated in the cloud, then it means that it will be great for you to have these cloud skills and how to navigate your way around both the cloud environment and then the on-prem environment as well. The next nice to have is software engineering skills. I mentioned earlier that data scientists, machine learning engineers, and then data engineers need a bit of software engineering skills. We are not saying that they should become software engineers, no. But then for them to be able to write clean and efficient code, for data scientists to be able to work with various APIs and then build data products and then think like an end user, then they should acquire software engineering skills. And just as I said earlier, I've recommended one resource that data scientists and then various data specialists can leverage on to acquire this software engineering skills that I've mentioned. But the next thing is project management too. So most of these data specialists work on projects. So for data scientists like me, I work on what I call data science use cases. And so if I want to be trained to be a data analyst, how do I go about it? Can you train me? When you compare UI UX to data analyst, which will be more profitable and easy to catch up? All right. So let me quickly answer this, and then I'll go on. So UI UX and data analysts are totally different domains, and I'm sure you are aware of that. So to become a UI UX designer, it means you're someone who is interested in building front-end applications, right? Someone who is interested in what the user will be interfacing with and how the user will basically work with the front-end environment. Now for data analysts, just as I said, data analysts work more with data. So each of these domains are totally different. For you to be able to go into a particular domain depends on your interest. Now, whether it is profitable or it is not profitable is dependent on how well you prepare yourself for these domains, right? There could be a UI UX designer who has put in the effort or has put in the shifts to be able to go into that domain and has established him or herself in that domain and is earning big time. And there might be a data analyst who has done one or two things and has also gone into the domain and is also earning sufficient amount of money. For a role to be profitable, it depends on how much you prepare yourself and how competitive you become. There are a lot of data analysts out there. I have to be honest. There are a lot of data scientists out there. There are a lot of machine learning engineers out there. But what sets you apart from these people will determine how profitable the role becomes for you, right? In the general sense, it is profitable, like I mentioned earlier. But for the role to be profitable for you depends on how much effort you put into the role. UI UX is profitable, data analyst is profitable. But again, that is dependent on how you prepare yourself for that role. Now, I've mentioned a couple of resources to get you started to become a data analyst. If you need any assistance or mentorship, that is fine. You can reach out to me and then I'll guide you along the way. I'll give you advice. I'll give you other resources that might comprehend or that might complement whatever task or whatever resource you have at your disposal. Now, again, if you want to go into this field, you need to be dedicated and disciplined. It's not a field we go and then we brush off and then we leave. No, it's a field where we continuously learn and evolve. The data space is continually evolving. There are new tools coming up every now and then. So if you want to establish yourself in this domain, then it means that you are dedicating yourself to continuous learning, to continuous improvement. And in doing so, you end up with a more rewarding role along the line, right? So I don't know if I answered your question, but then if any other question comes up, please pop it up into the chat and I'll be glad to answer. So we've looked at some of the nice to haves for data scientists, data analysts, and data engineers. And project management is also very important. You have to learn how to use various project management tools like Jira, ClickUp, and Trello. You need to learn how to write various documentations, and you need to learn how to engage with various stakeholders as well. Now, what are the next steps? So if I'm a young lad, I'm a university graduate, or I'm someone working in a different field, and I want to go into the data analytics field, what do I do? I've listed a couple of tasks that are performed by data analysts, data scientists, and data engineers. I've also included some resources out there that might help you to prepare yourself for a career in each of these data specialties. Now, after you've gone through all of these resources and have abreast yourself with the tools and skills, what are the next steps? And that is what we want to look at. So the next step is to build projects and then portfolio. There are two things that every organization out there looks out for data specialists. And one of them is projects, and the other is certification. I'll explain certification shortly. So projects is very, very important. It is a demonstration of the skills you've acquired within your learning journey, right? So you put everything you've learned, everything you've acquired into practice. And that is what you can show to recruiters. That is what you can show to organizations who want to recruit you or who want to employ you. Now, there are various platforms by which you can build projects or you can build your portfolio. And I've listed my top 4. And then first and foremost, the very first one is the forage. Let me quickly share my screen and then we look at how the forage looks like. So this is the forage platform. So I'm a data analyst, a data scientist, and a data engineer. And I've gone through all the skill sets I need to be able to start a career in this field. Now it is time for me to work on projects. Where do I get real world data to work on projects? And what kind of projects should I work on? This is the answer for you. So you can basically visit this website, and then there are various organizations out there that are organizing different virtual internships and then organizing different projects and tasks for each and every one to perform, to gain real world experience in the field after acquiring the skills, right? So there are data analytics projects that you can enroll in. There are data science projects that you can enroll in. There are data engineering projects, and then there are software engineering projects as well. Now, these are projects that are being organized by top companies. So we can see from this section, all the companies out here that have organized virtual internships on the Forage platform. And then on this session, we can also see all of the domains that people, or the kind of virtual internships that people can enroll in. So at a quick glance, we can see here data visualization, empowering business with effective insights. The moment you click on a particular virtual internship program, it takes you to the next page where you get to see the tasks that you have to perform. Now, these are real world tasks. These are tasks that you work with real world data, and it's something that you can show to recruiters on your LinkedIn, on your CV, that you've successfully completed. So if we should move down here. So the very first bit of the data analytics pipeline during the presentation, which is what problem understanding, is what we are looking at here. So framing the business scenario into a more comprehensive approach such that data analytics can be employed to answer the questions, choosing the right visuals, creating effective visuals, communicating insights. Once you are done with all of these tasks, the interesting bit about this platform is you are given the model solution. So I have completed the task, I have submitted it. Do I know if it's the right answer or it's the wrong answer? The model solution will tell you. So the model solution provided will help you understand the solution to the problem and also learn new ways of answering the problem as well. So there are various other internships that everybody can enroll in depending on your career interest. If you're interested in backend engineering, we have backend engineering here. And then so this is one of the projects that equipped me with my skills in machine learning, the data science and analytics organized by BCG. So the very first process you go through is business understanding and hypothesis framing. Then you perform exploratory data analysis, you perform feature engineering and modeling, and then finally you communicate your findings and then also recommend various solutions to business or to clients. So that is one resource that everyone out there who wants to work on projects can look at. Now, the next thing is your GitHub profile. I didn't mention this earlier, but it's important that you have an online presence where recruiter can reach you if they need to get in touch with you, or if they need to view or have an understanding of your background. One of such platforms is LinkedIn, which I'll talk about shortly. But then another platform is your GitHub. So this is a very simplified GitHub profile that I created for myself, which talks about what I'm currently doing, what I'm interested in, and then what my skill sets and then my interests are. And then this is my technology stack, what I can basically use to perform my tasks as a data scientist. And then this is where you can contact me. And then just a few statistics about my profile as well. So this is an online presence that I can share on my CV, so everybody can have access to them. Now, the next thing we want to look at is the Zindi platform. So this is the Zindi platform. This is where I took my first data science hackathon and won an amount of money, and also a 3-month internship with Google. So this is a platform basically for data scientists. So if you've gone through the entire data science pipeline or roadmap and you've equipped yourself with skill sets and techniques, what are the next steps? So just as I mentioned, you work on projects, you build your profile, and then the next thing is to engage in data science competitions. The reason I'm recommending this is because you get the opportunity to work on real world problems, right? Work with real world data sets and earn cash for partaking in such challenges. So there are various challenges for different level of people. So we have this challenge here, good for beginners. So if you started your data science career, and then you've looked at how to perform linear regression. This is a task that you can enroll in and then partake in, and then consequently earning cash as well. We have intermediate level competitions, and then we have other competitions purposely for acquisition of knowledge and then also for gaining points. And on these same platforms, they have what we call jobs, the jobs platform as well. So if you're part of Zindi community, you have opportunity to explore some of their job platforms as well. So you can see companies recruiting for machine learning engineer, for data engineer, for data scientist, and so on and so forth as well. And then they also have tutorial sessions for people who want to understand specific areas of the data science process. So how to perform data augmentation in NLP, and then how to also use various metrics in machine learning, how to perform cross-validation and so on and so forth. And then we have here, what makes you stand out, the art of CV writing for data professionals. So this is the Zindi platform, and you can also access it. And then the last bit of the project and portfolio part is the Tableau public platform. Let me quickly show this as well. I know time is far gone. I'll quickly finish it up and then I can answer questions that are popped up in the chat. So this is a very simple dashboard that I built way back in, I think, 2020 or 2021. And Tableau gives you the opportunity to publish the dashboard you built so that any recruiter out there who wants to validate your skill sets that you've indicated on your CV can have access to. So if it's on my CV that I'm very conversant or I'm proficient at using Tableau to build dashboards, what shows? How can I prove this? So this is where I put some of these projects on my CV with links as well. So everybody with this link can go to this dashboard and then have a view of the dashboard that I built. So this was published in March 2021, and so far 43 people have viewed the dashboard. So this is also another opportunity for you to showcase your skill set to recruiters or also have an online presence. Okay, moving from project and portfolio. Now, I mentioned that there are two things that most companies or recruiters look out for when they are employing data specialties or specialists. First, they look out for the kind of project you've worked on. So by all means, in an interview, they'll ask you to demo a project you worked on, right? And then two is certifications. What shows that you have the tenacity to continuously improve, to continuously learn and improve? And what shows that you, along the way, if there should be any change or there should be an evolution in the tool set that they are using. There was a company that I worked for who migrated from using relational databases to using NoSQL databases. And then they came back from NoSQL databases to relational databases again. So if you're a data scientist, it means that you should be equipped with either of these domains. So if it's relational databases, you should be proficient at that area. If there's NoSQL databases, you should also be proficient. Now, the interesting bit about the data domain is that there are tons of resources out there that allows us to be able to upskill and then grow and then acquire certifications that prove that we've been able to take that step. And one of them is the Coursera platform. So for Coursera, it's an online platform where you can enroll in various courses and then you pay on monthly basis to be able to attain your certificate. However, there are other options that you can also take part in. If you don't have money to pay, you can audit the course, but you'll not get a certificate. If you have money, you can easily pay for the course, and then once you are done, you get a certificate. Also, Coursera also provides the option of applying for financial aid as well. So if you don't have money and you are really interested in partaking in the course, then you apply for financial aid on Coursera and you'll be given to take the course. There is Udacity platform as well, which has tons and tons of resources. Sometimes I wonder why most people do not take advantage of some of these resources provided. Udacity is a platform whose courses or whose training is based on industry standard. So everything you learn from Udacity is readily applicable on the job market. So when you visit Udacity, the first thing you do is you scroll to the bottom and then you go to catalog. Oh, my network is bad. So the moment you get to catalog, it displays all the programs that they have on their platform. So data engineer, product manager, business analytics, data analyst, and all of these courses are paid for. To have access to the free courses, you drop down the price button and then you choose free. Now you can see all of the free courses here on Udacity with projects as well. The only thing is for these courses, you don't get certificates, but then you get valuable knowledge that you can apply on the job. These are well-structured courses with projects to buttress the course that you take, front-end frameworks, web tooling and automation. So many nice courses. And I wonder why most people are not taking advantage of some of these free courses. And just as I said, if you're someone who's interested in this domain, you have to continuously learn and improve. So these are some of the platforms that you can look at taking advantage of just to upskill in a particular area. So if you want to learn how to program in JavaScript, there is a course available, free course available for you to look at. If you want to have an understanding of what programming is, I've mentioned that, oh, okay, so as a data scientist, data analyst, you need to have programming experience. But to you, you're an amateur or you're coming entirely from a social background and you don't even know what programming is. This is a course that will introduce you into what programming is and why we use programming. And it's free. There are other courses as well that you can also explore. Now, what I want to talk about is the opportunity that this organization offers all Africans, so ALX. So ALX offers courses or programs to all African citizens from every nation to enroll and upskill in various IT domains, right? So we have cloud DevOps engineer domain, which is currently open. We have full stack developer domain, we have cloud developer, and then we have data analyst. So for people who are interested in becoming a data analyst, you can apply for this scholarship. And then it's in partnership with Udacity. And just as I said, Udacity programs are industry standard. So the project you work on speaks volumes when you go out there to apply for jobs. So we have the data analyst program here. We have the financial analyst, virtual assistant. We have the young entrepreneurs program as well. If you want to take this just to get an understanding of what entrepreneurship is. And then we have the full stack software engineer here as well. So ALX provides the opportunity for all Africans to upskill, get the right skills and knowledge to apply for some of these IT roles in Africa. And they are currently open. So for people who are interested, who are currently on the call, you can quickly zoom into this website and then apply for some of these programs. And then hidden. Where's my presentation slide? All right. Yeah, so we've looked at Coursera, we've looked at Udacity. We've also looked at W3 Schools, which is also another platform for learning different programming languages. We've looked at ALX and then DataQuest. So if you're a participant for the Africa Digital Skills Conference, DataQuest is offering 100% scholarships on their platform. So for anyone who's interested in applying, just go in here, fill in your details, and then punch the voucher that you saw on the slide. And then punch this voucher into the coupon section. And then voila, you have 100% scholarship, 6 months opportunity to learn data science, to learn data analysis, to learn business intelligence, to learn Power BI, and so on and so forth. And again, also look out for some of these programs that are being organized by Microsoft to get free coupons for taking cloud certification in various domains. So we look at Microsoft Ignite, we look at AWS Reskill, and then the boss of them all, which is YouTube. So you can visit YouTube for any tutorial at all that you want to upskill, and there are tons and tons and tons of resources on YouTube to aid in your quest as well. And then lastly, we want to look at the job search, CV, and cover letter. What do I need? How do I draft my CV? And then where do I search for jobs? And how do I go about being competitive in the market to apply for some of these roles? So first and foremost, you need to optimize your LinkedIn profile. And you also have to follow companies and people in the same domain as you are interested in. And then be active on the platform and confidently reach out to recruiters as well. And then I've also provided a link to improve your LinkedIn profile from your profile picture to recommendations. You can follow that link and then go through the series of steps just to optimize your LinkedIn. A lot of young chaps out there don't really understand how LinkedIn works, and they underestimate the power of LinkedIn. I can tell you the number of recruiters who have reached into my inbox just to share job opportunities with me because of an optimized LinkedIn profile. It can take you that far, and it's a starting point for you as well, just to be visible on a digital platform. Now, the next thing is your resume. Usually for someone who's now starting out into the data science or data analytics or engineering field, usually we build our CV in such a way that they become multi-paged when we know we have less experience in this field. Every advice I give to every person out there who's starting out a career in this field is to build a one-page resume. It works, and you don't have to put everything onto your CV. Surely there are some stuff on your CV that are not necessary that you can take out, right? So try as much as possible to format your resume to a one-page resume, and then try and include action words. You've gone through the data science roadmap or data analytics roadmap. You've learned various tools. You worked on projects. So when you're describing some of these projects or tasks on your CV, try and use action words and then quantify them. So build a machine learning model that can generate or that can predict if a customer will default on loan with 80% accuracy. Just quantify some of the tasks that you perform, and also use action words as well. And then add interest outside of work. A lot of people, when they are asked to add interest to their resume, they go about, okay, I like reading books, I like watching documentaries. They are true, but recruiters out there also want to learn the social parts or the social side of you. Apart from work, apart from studying, what are the other things that you like to do? You like to play football? Do you like to go singing? Do you like to go hiking? Whatever it is, put those interests on your CV. And then here's a link to building an eye-catching resume as well. If you want to follow the link, it's here available. And then we also have the cover letter page as well. So there are most organizations out there or recruiters out there who also seek cover letters. Now, this is where a lot of job applicants fall short. They see a particular job advert online, and then they are interested in applying for the job. The job requires that they submit a cover letter and then a resume. However, on the cover letter, they've placed an asterisk or optional on the cover letter. And because they see this, they don't submit a cover letter. The cover letter is basically a way of selling yourself. Just as I said, you are keeping a one-page resume. You can't put everything on the resume. The cover letter provides the platform for you to sell yourself out without limiting yourself to just one-page resume. So everything that you've said on your CV, expand on them on the cover letter, comprehensively describe your achievements, sell yourself in relation to the job that you've applied. I built a tool that was able to generate $100,000 revenue for the organization that I work in. And I use Python, I use SQL, I use that and that. I built a dashboard. Just sell yourself out on the cover letter. It's the only way the recruiter will get to know some of the things that you've done, achieved in context. Now, how do you apply for jobs, especially if you're a young lad? So just as I said, usually the preparation time spans between 3 to 6 months. And what do you do within this period? Are you also working on another business, for another company? Are you at home or a young student who just graduated and is now learning data science within that 3 to 6 months period? How do you make money? This is where freelancing platforms comes in. So you've acquired some sufficient skills. So David here presented to you that when you are going through your data analytics roadmap, make sure that you know how to use Python programming. Make sure that you know how to perform data analytics. You've gone through all of these things and you have the skill set. how can you monetize the skill sets that you've acquired? And this is where the freelancing platforms provide the opportunity for you. There are some basic tasks out there that people are paying $10, $15 per hour just for people to complete for them. And it's only up to you to use the skill sets you have to be able to complete some of those tasks and then be earning something small into your pocket. Whilst you know that your preparation period lasts for about 6 months, you know on the side, you can also use the skills you are learning to earn some small income. And then once you're done with the whole 6 months preparation period, you can apply for a more suitable job that pays you monthly salary and can still be working on some of these freelancing platforms. And I recommend Upwork as a freelancing platform that you can look at if you want to apply. And then job posting sites. I use LinkedIn a lot for searching for jobs. The last time a friend of mine asked me if I sleep on LinkedIn. I told him, yes, I sleep on LinkedIn because, listen, if you're in the data space, the demand is so high that sometimes it's not really about applying for jobs. Sometimes I go there just to read the job description to see where I'm falling short, what I need to upskill with, where the gap is, right? But every now and then, every minute, every second, jobs are being posted about this data science or data related fields. So take advantage of some of these job posting sites. There is LinkedIn, there is Indeed, there is Glassdoor, there is AngelList, and a couple of them as well. And then finally, what a lot of people don't do is to visit companies they are interested in, look at their career pages and apply for jobs available. Most of these job posting sites don't post jobs from some of these company career websites. And then another thing is, there are a lot of scammers on the market, right? So you go out there, you apply for a job, your CV ends up with someone who's a scammer out there, probably an Indian somewhere. And then they use that information that they've gotten just to manipulate you to get other information as well. You don't want to be caught in that regard. So one of the best places to apply for jobs is to visit the company you are interested. If you see the job on LinkedIn, if you see the job wherever it is, visit the company to verify if those jobs are also being advertised on their careers page. And it might come to you as a surprise that you might see some jobs that are on their company's career websites, but then are not on the job posting sites that you were searching initially. So on a high level, these are some of the things that you can do to prepare yourself for the job market. LinkedIn optimization, writing a one-page resume, writing a comprehensive cover letter. And then whilst you are preparing within 3 to 6 months period, take part in some of the Upwork platforms, apply for jobs, complete tasks, and then earn small income. Also continuously search for some of these jobs, not because you are interested in applying, you know that you want to be ready after 6 months, but then you want to know the kind of things, the skills, the tools that you need to acquire to complete, and what some of the companies out there are looking for. So once a while, just go to some of these job search portals, look for data scientist, data analyst, data engineer. What are they looking out for? Okay, they need SQL, they need Python, they need Excel, they need VBA, they need that and that. Where am I falling short? And how do I upskill? So just visit those places once a while, just to be able to get a fair idea. And after your training period and you are ready, after the roadmap, you can look at some of these company career pages, visit some of them, and then apply for some of the jobs. I've had 2 jobs basically by visiting this company career pages. Not necessarily the job posting site, but the company career pages. And some of these jobs weren't present in the job posting site. So this brings me to the end of my session. And there are some questions in the chat. Let me quickly run through them. Okay, so Xiaomi is asking, can one become a data scientist without going to university to study it as a course? Certainly. Data science programs or data scientists out there or companies out there, they don't really need a formal education in the data science field to employ you. What you need to do is to basically upskill, work on projects, and once you can do the job, that is the only thing that they will require. You don't have to go to a university to study to become a data scientist. You don't have to go to a university to study to become a data analyst. The only instance where university education becomes imperative is when you want to take up leadership roles, right? So there are some organizations, for them to employ you into their leadership role, you need to have a master's degree, right? But on a high level, fundamentally, you don't really need to go to university to become a data scientist. There are tons and tons and tons of resources out there that you can leverage on to become a data scientist. Recently, Google was saying that now they will employ people who take their professional certificates. So if you've not been to the university and then you take some of their professional certificates, you can apply for a job at Google. You don't really need to go to the university. And then I hope I've answered your question, Chami. And then the next question from Ofugu was, so how do I contact you? I don't have an IT background. Can I succeed because most employers only consider people with experience? Yes, I will say this. You can complement your experience or you can supplement your experience with projects, right? I was working at Analytics Services as a data scientist only for 4 months at the place, full-time employment. And then I applied to Consolidated Bank and I was accepted. During the interview process, I had to demo a project I had worked on. And it was one of the projects that I worked on the virtual internship platform that I showed you earlier, right? So you don't have an IT background, but data analysis, data science, data engineering is for everybody who is disciplined and willing to put in the shift, right? When I started the presentation, I told you I came from strictly a biomedical engineering background, right? Where my focus was mainly in health. But then I quickly made a career switch and I sat at home for a year just to upskill myself to get into this domain. So it doesn't matter whichever background you're coming from. Every employer wants to see if you can do the job or not. And then I hope I've answered your question, Ofugu. How do I contact you? So yeah, I'll share my LinkedIn profile. So you can contact me. You can reach out to me when you want. And then Bright is also asking, please, can you share the link for updating your LinkedIn profile and CV? Thanks. No problem, Bright. So I'll share the presentation slides. I'm sure the organizers will share the slides with everyone who attended the presentation, but I will also try and pop that up in the chat. Let me quickly get that. So that should be here. Okay, so right before that, let me answer the final 2 questions and then we can end the session. So can you please send us the recording? Sure, so the recording will be shared with you by the facilitators and it will be made available. So I'm sure it will be available on YouTube. You can access the recording on YouTube, and then also you can contact any of the organizers as well if you want the recording. What are some of the books you will recommend for data scientists? So there are tons and tons and tons of books that I use out there. And I must say that one of the best books I used was basically Python programming for everybody. It gave me a solid understanding in Python programming, and then it introduced me into the world of data analytics, where I work with different data sets from websites. I scrape data from websites using Beautiful Soup, and so on and so forth. But yeah, there are good books out there. One of the recommendations that I've placed, or resource that I've placed under the machine learning bit or data science bit, is Machine Learning Mastery. So Machine Learning Mastery is a platform that you can visit just to upskill with data science. And he has books for every single step in the data science pipeline. So if it's about data transformation, there's a book available for that. If it's about machine learning, if it's about pipelines, whatever process you want to go through in the machine learning bit, he has a book available for that. So you can visit Machine Learning Mastery to download most of his books. And then you can also look at Python for Everybody by Charles Severance as well. And then there are a couple of good books out there that you can also search just to get the understanding that you need in a particular field. I'm sure the resources that I've shared so far will be sufficient enough to walk you through whatever you need to go through to start your career in any of those data specialties. I hope I've answered everybody's question. Let me quickly share the resume update. So this is for optimizing your LinkedIn profile. And then for resume, let me share that here. But yeah, you get access to the slides, so it shouldn't really be a problem. And then for cover letter, and for those who want to reach out to me on LinkedIn, do I even remember my LinkedIn profile? So if you want to reach out to me on LinkedIn with any question at all, I'm available to assist. So I've also popped the link in the chat. You can check it up. Yeah, so I've shared my LinkedIn profile in the chat. You can check it up and then have access to it. And then the recorded version will be shared with everybody on the call. If it's not available, you'll be prompted that the recorded session is also available on YouTube. You can access it. So right after the session, I'm sure the facilitator will contact everybody who wants access to the recorded session. So I hope I've answered everybody's question. And if there are no further questions, then I guess we can bring the session to an end. So thank you everyone for making time for attending this session. And I hope that the session has been super, super fruitful for you. And you've been convinced or you've been informed enough as to which data specialty or which data domain you want to go into. So I'm available on LinkedIn. You can reach out to me whenever you have any questions. You can also follow me on LinkedIn if you need to stay updated with some of the things that I post. I think there's another question in the chat. How long will it take me? So again, I didn't add timelines to the roadmap because everybody has a different approach for studying, and we all study at different pace, right? So how long it will take depends on how disciplined you are and how willing you want to put in the effort. So for me, I didn't have access to these resources. I remember for the very first course that I took, I paid for it. But afterwards, I've always been getting scholarships and then free vouchers to take courses, right? So right from the beginning, it was a bit difficult. So I spent a year and I didn't really have a mentor, which I also didn't mention. It's important to look out for someone who's also in the field, who you can talk to and who can advise you and who can answer most of your questions so that you move quickly with whatever it is you are studying. Right. So on the average, it should take you between 3 to 6 months if you want to start your career as a data analyst or a data scientist, on the average. But again, it's not about how fast you can learn or how fast you can complete. It's how you can apply everything you've learned on the job, right? So I advise that you be patient, you take it one step at a time, make sure that you understand it before you move to the next bit. That is why I mentioned that it might seem too long for you. So whilst you are acquiring the skills, apply for some jobs on the freelancing platform where you can apply those skills, right? You can monetize the skills that you've learned and you'll be earning some passive income along the way. So anonymous attendee, sorry. I hope I've been able to answer your question. Yeah, so I think I've answered all the questions that popped up. Will 7 months be enough if I devote 4 hours daily? Sure, that will be enough. That will be enough, way enough for you to complete whatever resource you need to acquire and then also work on project as well. So yeah, that will be enough. All right, so if there are no further questions, thank you very much, everyone. And then I wish you the very best in everything that you endeavor to do or achieve. Bye.